Alright, 5.1 is solving systems of equations, and more specifically 5.1 is by graphing. You're going to find out in the next couple sections there's also going to be other methods to solve systems, but the first method is simply by graphing. So a system of equations just means that there's more than one equation within the problem. So you're used to just doing like y equals 2x plus 5. Well, now they're going to give you two of those within one problem. So for example, y equals 2x plus 5 and y equals 4x minus 1. And again, I just made those up, but as long as there's two within one problem, that would be a system. You could have more than two, but you guys will just be working with two variables. So how to solve a system means that you have to find the answers to both lines, okay? So for example, if we have something like y equals, for example, negative 2x plus 5 and y equals 4x minus 1. You should know how to graph those on a coordinate plane, but now you're going to graph both of them on the same plane, and the solution is simply where they cross. And your solution should be written as an ordered pair. So for example, if this crosses at 2, 3, I have no idea if it does, I'm just guessing. So if it crosses at 2, 3, the point 2, 3, solution is going to be 2, 3. You have to make sure you list them both, because this is going to be your x value and this is going to be your y value. Okay, so one of the first things you're going to have to do, even before you graph, is they just want you to be able to check a solution. So, for example, if they give you something like 2, 5, they're telling you that this is a solution, and you have to check it in these equations. So the first equation is x plus y equals 7, and the second equation is 2x minus 3y equals 11. So what you're going to do is you're just going to plug in. There's your x, and there's your y. And you're going to simply go plug it in, and you have to make sure it plugs into both. So I'm going to do this top one first. So 2 plus 5, does that equal 7? Yes, that one checks. So now we go to the next one. 2 squeezed with 2 minus 3 squeezed with 5, and we're going to check to see if that's 11. So 2 times 2 is 4, minus 15, is that 11? Nope, it's not. And this equals negative 11, so this is not a solution. So when they ask you to check this solution, it is not, because it must meet both equations, and this one only meets one. Okay, so another example, check the given solution. So you're going to check negative 2, 0. And again, your negative 2 is your x, and your 0 is your y. And you want to check that in this. Y equals negative 2x minus 4. And y equals x plus 4. So again, you're simply going to plug in the negative 2 for the x and 0 for y. So I'm going to do this top one first. So 0 equals negative 2 times negative 2 is a positive 4. 4 minus 4 is 0. So it checks because it equals 0. Again, we got to go down here and do the exact same thing. So 0 equals negative 2 plus 4. No, it doesn't, because 0 over here and this equals negative 2. So this does not check. So again, this over here is not a solution because it has to match on both. Alright, so the next thing you're going to have to do is actually graph. And again, the solution is finding where the lines cross. So you literally just graph the lines given and then tell me the point where it crosses. So we're going to start with y equals negative 2x plus 5 and y equals 4x minus 1. So again, it doesn't really matter which one you graph first. I usually just do the top one. So I'm going to go up 5 for my starting point, and then I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. and do a few just so that you can have your points there. And then we'll go to the other line, down 1, and then it says up 4 over 1. And bingo, right there you can see where it crosses. So here's your yellow line, here's your blue line, and you can see that my solution is right there because they both cross at that point. Obviously my lines aren't drawn very well, but the dot you can see is exact. So you don't just say there's the solution, you have to actually count the ordered pair off to the side. So you start at the origin and we go over 1 and up 3 to find the solution. So your solution set is 1, 3. So that literally means you could plug in a 1 for the x's and plug in a 3 for the y's, and these would come out perfectly over here. Okay, so the next one, again, another example, y equals x minus 2, and y equals negative x plus 4. It is important that they're in y equals. That makes it easy to graph. So you may have some that aren't. Just put them into y equals. That will make your life easier. So again, I'm going to start with the top one just because, and it says down 2, and then it just says up 1 over 1, up 1 over 1, up 1 over 1. So there, you can put in your 1 over 1 if you're confused where I just got that. Down here, it's going to be a negative 1 over 1. So I've got my line here. I hope I have enough dots. And then up on the second one, going up 4, and then down 1, right 1, down 1, right 1, down 1, right 1. And you can see right there, that is where it crossed. So we're going to write that ordered pair. So again, off to the side, you have to take the time to write from the origin, how many did you go over? 3. And then how many did you go up? 1. So again, your answer is 3, 1. So the x value is 3 and the y value is 1. And that would fit both of those equations. Okay, so word problem example. It says you want to work out for 10 more minutes at the gym. You want to burn 60 more calories. You know that an elliptical burns 10 calories per minute and the treadmill burns 2 calories per minute. How long should you do each activity in order to burn exactly 60 calories? So again, what you could do is you could graph this, but in order to graph it, we need some equations. So first of all, the first thing you're going to do is figure out what you want your variables to be. And the nice thing about systems is there's always 2 activities, or 2 kinds of fruit, or 2 different types of pizza. Whatever you're talking about, there's always 2 different kinds, and you get to choose what you want your variables to be. So let's say, for example, we want to call x the elliptical minutes, because we're doing each activity, and I'm going to have the y be the treadmill minutes. So the first equation just is the minutes. So I'm going to go through and I want to do 10 minutes at the gym, and I'm doing both of these activities. So literally I'm just going to write x plus y equals 10. The minutes on the elliptical plus the minutes on the treadmill cannot exceed 10 minutes. I only have 10 more minutes at the gym. So that's my first equation. My second equation, I'm going to talk about the calories. So the calories, and calories. So I know the total is 60 calories, and then the elliptical is the x one. So I'm going to squeeze 10 with x because it says you burn 10 for the elliptical, and you only burn 2 for the treadmill. So that's going to be my second equation. So first thing you want to do is change these into y equals. So this first one, I just have to go minus x and minus x. So I'm going to go plot y equals 10 minus x. So I start down here, we've got 5 right here and 10. So my first dot is going to be at 10, and then my slope is just down 1, right 1, down 1, right 1, down 1, right 1. And again, I'm just going to keep going until I hope I have enough. So there's my first line. My second line, again, I've got to solve for y here. So minus 10x, and then divide by 2, and divide by 2. So y equals